Okay, hi, in this video I'm going to show you how to determine when is the object speeding up or when is the object speeding down. So we'll be using the same function from the position particle problem. So the function is t cubed minus 9t squared plus 24t. So in this case, it's already defined that the velocity and the object is speeding up when the velocity and the acceleration have the same signs, meaning if it's either they're both positive or they're both negative. Okay, so you should have positive, positive, negative, and negative. So velocity and acceleration. Now for us to identify where exactly is the object speeding up or speeding down, we need to use the velocity function and the acceleration function. So the velocity is basically the derivative of the position function, while the acceleration is the second derivative of the position function. In other words, it's the derivative of the first derivative. Okay, so let's first find what is the first derivative. So from t cubed minus 9t squared plus 24t, this is 3t squared minus 18t plus 24, which is a quadratic function. And a quadratic function has a graph which is the parabola. So it's either it's in this orientation or in this orientation. Now this will happen if the coefficient of t squared is positive, and in this case it's actually positive, so you expect the graph of this quadratic function in this orientation. Okay, the second derivative, so is the derivative of the first derivative. So this is 6t minus 18, and this is a linear function, so the graph must be a line. Okay, so it's a straight line, either it goes this way or it goes this way. This if the slope is positive, in this orientation if the slope is negative. But as you can see, the slope is 6. Remember, y equals mx plus b, so this is m. The slope is 6, so it should follow this direction. Okay, so we need to graph the two functions for us to see where they are positive, or both positive, and where they are both negative. Okay, so keep in mind these functions, so we will be graphing these two functions. Okay, so we have the two functions. The first derivative is equal to 3t squared minus 18t plus 24, and the second derivative is equal to 6t minus 18. So this is for the velocity, and this is for the acceleration. So we need to create an xy plane, so let this to be our y-axis, and let this to be our x-axis. So this is x. Okay, so let's graph the quadratic equation first, or the quadratic function. So to graph the quadratic function, we need to find the vertex of the quadratic function. So for the vertex is, okay, the value of the x can be obtained through the formula negative b over 2a, where a is the coefficient of t squared, b is the coefficient of t, and this is actually c, but you don't need that in the formula. So this is negative of negative 18, so this is the b, divided by 2 times the value of a, which is 3. So this is 18 divided by 6. 18 divided by 6 is equal to 3. So the vertex will have or will be at x equals 3. So since a vertex is a point, we need to know where or what is the y value for this. So all you have to do is to place the value 3 on this function. So that will be 3 squared minus 18 times 3 plus 24. So this will be 3 times 9 minus 54 plus 24. This is 27 minus 54 plus 24. This is negative 27 plus 24. It should be at negative 3. Okay, so at x equals 3, so 1, 2, and 3, the vertex will be at negative 3. Okay, so again we said this will have this orientation. Okay, so if this is the vertex, it will go up on the left and it will go up on the right. So for sure it will be passing through the x-axis. So just for us to know at what values of x will the graph pass through the x-axis, we just need to find the x-intercept. So x-intercept will happen when when y, this value is equal to 0. So you have 0 is equal to 3t squared minus 18t plus 24. This is the same as 0 if you divide by 3. This is t squared minus 6t plus 8. And this will be t minus 4 and t minus 8. So it will pass through the point 2. It will pass through the point where the x equals 4. So this will go this way. Now, so we need to graph the linear function. Okay, so this is 6t minus 18. A line can be easily graphed by using the intercepts. So first you have to find where is the x-intercept and where is the y-intercept. To find the x-intercept, just simply set this to 0. So this is the line that we need to graph. So you have to set that to 0. So from f double prime of t, this is the acceleration. So you have 6t minus 18. You set this to 0 and you have 6t minus 18. This means 6t is equal to 18, and this will give us t is equal to 3. So it will cross the x-axis at t equals 3. So this is the point. And then to get the y-intercept, you do the same thing, but this time you make, so from acceleration, the f double prime of t as 6t minus 18, you make the t equal to 0, and this will be 0 minus 18, and this will be negative 18. So let's just assume that this is the negative 18. So if you graph the line, so it should pass through the 2 points that we obtained. Okay, so after graphing the two graphs or the two functions, it will be easy for us to find where is the particle speeding up and where is the particle speeding down. So again, keep in mind that the object is speeding up when the two functions are both positive or the two functions are both negative. Okay, now how do we easily determine those intervals? All you have to do is to focus on the points where you cross the x-axis. So it's crossing the 2, it's crossing the 3, and it's crossing the 4. So you just check what's happening before the 2, what's happening between 2 and 3, what's happening between 3 and 4, and what's happening after 4. Okay, I want you to focus your attention on the interval 0 to 2. So as you can see, on this interval, the parabola is above the x-axis. That means it is positive. While the line is below the x-axis, so that means it's negative. So anything below the x-axis is negative. Anything above the x-axis will be positive. So since they have opposite signs, then we can say that the particle is speeding down from 0 to 2. Okay, then we investigate what's happening between 2 and 3. If you look at the parabola, the graph of the parabola is here. It's below the x-axis, while the graph of the line is also below the x-axis. So at this interval, it is speeding up. Okay, SU is speeding up. And then we go to 3 to 4. So 3 to 4, the line is above the x-axis, the parabola is below the x-axis, so this is speeding down. Same with 0 to 2. Okay, but after 4, if you look at the graphs at 4 onward, so you have positive parabola is above the x-axis and positive line is above the x-axis. So this is speeding up. Okay, so going back to the question, so when is the particle speeding up? So from what we found here, it is speeding up. So let's just say SU speeding up. That will be from 2 to 3, and then it will be speeding up again from 4 to positive infinity. It is speeding down from 0 to 2 and also from 3 to 4. Okay, so just to review how we answered this problem, the key is you need to know how to graph rather a parabola and a line. Okay, so for the parabola, you need the formula x equals negative b over 2a to find the vertex, and you have to use the idea of intercepts to find where exactly is the graph crossing the x-axis. So for the line, you also use the intercepts. So idea is if you want to look for the x-intercept, you have to set the y equal to 0. If you want to find the y-intercept, you have to set the t equal to 0. And once you graph it, you keep in mind the main idea, the object is speeding up when the two functions have the same signs, either both positive or both negative. Otherwise, the object is speeding down. Key in visualizing the graphs will be focus on the intercepts, the x-intercepts. That will divide the interval, okay, or the number line into several intervals. Okay, so that's it.